Okay guys, let's take a look at the study guide for chapter 1. I'm going to work through each of these problems and feel free to scroll through if you know that you got certain answers right, but I'm going to step them out as well. So number 1, x plus y minus c, they're asking us to evaluate, so that means we want to substitute the values in. So it's going to be 0.5 plus 1.5 minus 10. Now because we have two different operations going on here, we have to follow PEMDAS. Go from left to right. 0.5 plus 1.5 is going to give us 2. And then 2 minus 10 is going to equal negative 8. So the answer to number 1 is negative 8. Number 2, z minus y minus x. I'll put it up here so I don't run out of room. It's going to be 10 minus 1.5 minus 0.5 or 0.5. So first I do these two. 10 minus 1.5 is 8.5. Minus 0.5 is going to just give me 8. So the answer to number 2 is 8. Number 3, I'll use a different color because it's kind of squeezed in there. Draw a line. We have x times y, so that's going to be 0.5 times 1.5. If we remember when we multiply decimals, you want to line them up like along the right. You do not want to line up your decimal points. So they should be flush along here. And then let's get that line out. It looks like a weird division sign. 5 times 5 is 25. 5 times 1 is 5 plus 2 is 7. We're going to move our decimal point over 1, 2, 1, 2. So for this one, the answer is 0.75. And then we have number 4, z over y. So it's going to be 10 divided by 1.5. When we divide, our top number is going to go on the inside. 1.5 is going to go outside. This really has a decimal point here, and because we can't keep our decimal point outside, we want to move this once and then correspondingly this once as well. Decimal point is going to come straight up then, and now we're just dividing 15 into 100. So 15 does not go into 1, 15 does not go into 10, but 15 does go into 100, and if I work it out, I think it goes in 6 times. 15 times 6 is 90. So I subtract and I get 10. I'm allowed to bring one number down each time. 15 goes into 100 6 times. And I start to see that I'm going to get a pattern. The 0 is going to come down. We're going to get the same thing. So the answer here is 6.6 repeating, or you can write 6 2/3. That's fine as well. Okay, let's take a look at number 5. We have this to tell whether the sum is always, sometimes, or never negative. And number 5, the sum of two negative integers. So that means a negative plus a negative. This is always going to be negative because you're going further down the number line. Negative plus a negative is always negative. Number 6, the sum of a negative integer and a positive integer. This one is sometimes negative. And the reason is because let's say we had negative 10 plus 3. This is negative 7. But what if we had negative 3 plus 10? This is positive 7. So sometimes it's negative, sometimes it's positive. This is where we look for the bigger sign. The number with the bigger sign is going to be the one that determines it. So here it was the 10. Even though this was negative, this one had the bigger sign. So that's how that came to be. Moving on, let's take a look at number 7. Evaluate the expression when n equals 4. So really this is going to be 4 to the 4th, meaning 4 times 4 times 4 times 4. Now I like to do it based on what I know. I know 4 times 4 is 16, and so same goes there. And then I can just multiply 16 times 16, 6, 9, carry the 0. This is going to be 6, 1. I get 256. So the answer to number 7 is 256. Excuse me. Okay, let's look at number 8. We have n to the 6th. So this is going to be really 4 to the 6th, which is 4 times 4 times 4 times 4 times 4 times 4. Now, we just did 4 to the 4th, and we know that this is 256. And we know that this is 16, so no need to rework all of it. Let's just take it from that step. 256 times 16 is going to be 36, carry the 3. 5 times 6 is 30, plus 3 is 33. 6 times 2 is 12, plus 3 is 15. So that's done, that's done, that's done. Now place my 0 in. 1 times 6 is 6. 1 times 5 is 5. 1 times 2 is 2. My final answer is 4,096. Okay? Nice job, guys. Nice job. Alrighty. Moving on. I'm going to actually, let's see if, I'm going to try something. There we go. Okay, I erased those answers so that I have room to do numbers 9 and so on, because these are going to involve a little bit more work. So number 9 I'm going to put right here. The problem says 3 times the bracket of 100 plus 5 squared plus 18 plus 2, and that's what we have. So first thing we want to take a look at is, remembering this, our parentheses, because they're inside the brackets. So we look here first, and then we follow order of operations again. 5 squared is 25. So neatly, I'm going to rewrite everything that showed up above. This is number 9. That's not a 9.3. Now I'm going to simplify what's inside of our parentheses. So I get 3 times 100 plus 25 plus 18. Need to do a little work on this side, please do. It's going to get 43 plus 2. Now I can add everything inside of my brackets. 100 plus 43 is 103. 143 plus 2 is 145. And now I can multiply 145 times 3. 12, 13. I get 435. Alright, let's try number 10. We'll use green, a teal for this one. We have 4 times 10 minus 1 plus 7. So it's going to be 4 times 10 minus 8. 4 times 2, which gives me 8. Number 10 is going to be 8. Alright, number 11, we'll use midnight. I might be able to do this one here. We're going to do parentheses first. So I'm going to subtract 6 minus 3 is 3. So 26, this is what I get, 3 squared. 3 squared is 9, so that's my next order of business. 26 minus 9. And 26 minus 9 is 17. Number 12, we're going to, when we have fractions, you can think of the numerator and denominator as separate entities. So we want to simplify the numerator first, and then the denominator, and then do any dividing that needs done. So we're going to add 2 plus 4 because they're in our parentheses. So I get 6 squared over 9. That's then going to give me 2 times 36, because I have to do my squaring next, over 9. 2 times 36 is 72 over 9. My final answer comes to 8. And I do apologize, it's a little bit all over the place here, but hopefully you're able to follow the actual work and carry through with me. Alright, number 13, we're evaluating the expression using the given variables. This is going to be 8 squared plus 15. 8 squared is 64. 64 plus 15, 79. Number 14 is going to be 3 times the quantity t minus r, quantity squared. So really this is 3 times 15 minus 8 squared. 15 minus 8 is 7, so I do what's in parentheses first. Now I have an exponent, so the only thing being squared is a 7. So I really have 3 times 49. And a little bit of side work. 49 times 3 should be 147. It is 147. That's the answer. Number 15. Substituting my values in. It's going to be 8 squared minus 4 over 15 plus 5. 8 squared is 64, so we have 64 minus 4 in the numerator. 15 plus 5 is 20. It's going to give us 60 over 20 when we subtract 64 minus 4. Final answer of 3. And the last one, number 16, 5r minus 2t all divided by r plus 2. So this is really 5 times 8 minus 2 times 15, all divided by 8 plus 2. So in the numerator, simplify that first. We have 5 times 8, which is 40, minus 2 times 15, which is 30. All that's going to be divided by 8 plus 2, which is 10. Then we simplify a little further. 40 minus 30 is 10. 10 divided by 10, 1. So the answer number 16 is 1. All right, 17. We have some absolute values going on here. So I like rewriting the whole thing with the exception of what the variable would be. So I'm going to actually go through and do that for all of these. I'm going to leave a space where the variable would be. If there's absolute value, I'm going to leave it as an absolute value. If there is nothing, just a variable, as we saw in number 19, which I just did, I'm going to put parentheses there. So absolute value, I left a space. Here I put parentheses. I'm rewriting, all I'm doing is rewriting the whole expression with the exemption of my absolute value, my variable. Okay. All right, so let's just take it one at a time now. I just went through and set it up, but let's see. The first one, 17, says the absolute value of negative a minus 5. So I have the absolute value of negative blank minus 5. A is negative 12, so this is really the absolute value of negative 12. Well, the opposite of a negative is a positive, so these become positive. But we know anything in absolute value is positive anyway, so really this is just 12 minus 5, or 7. Number 18, we have 6 minus the absolute value of a, so in this place we can put negative 12, plus the absolute value of negative a, so that's negative 12. Looking through this, we get 6 minus the absolute value of negative 12 is positive 12, plus the absolute value of negative 12 is also positive 12. So we have 6 minus 12, which is negative 6. Negative 6 plus 12 is positive 6. So that's your final answer to number 18. Number 19, we have negative a plus 9. A is negative 12. So really this is negative 12, which is the opposite of negative 12 or positive 12. 12 plus 9 is equal to 21. And the last one, 10 times the absolute value of a. So 10 times the absolute value of negative 12 is 10 times 12. 10 times 12 is 120. Well done, guys. Well done. All right, maroon for the last 4 on this page. Find the value of the expression. So we are going to go through, there's no equal sign, so it's an expression, and we're just going to take it from left to right. Even though they're all being, in this one, all being added, this plus this plus this, I think if you just go from left to right, it makes it easiest and you're most likely to get the correct answer. 1 plus negative 5 is negative 4. Negative 4 plus 9 is positive 5. And 5 plus negative 3 is positive 2. So that's the answer to number 21. 22, left to right. Negative 15 plus negative 8 is negative 23. Negative 23 plus negative 4 is negative 27. Negative 27 plus 11 is going to give me negative 16. Okay? 23. 7 minus negative 8 is really the same, add the opposite. Really, this is 15. 15 minus 4 is 11. Okay? And 24. Negative 10 plus 1 is negative 9. Negative 9 minus 15 is going to give me negative 24. And negative 24 plus negative 8 is negative 32. Okay? Hope you're doing great. If you have any questions, maybe rewatch it. We're going to go on to the next page now. Let's see. There we are.